Hello, my name is Monica and this is Lab 1 Charged Tapes. For this lab, we observed the interaction between two charged pieces of tapes and determined the excess charge of one individual tape. A computational model was then created and the results were compared to the lab experiment. In the end, we found that the tapes were positively charged and the magnitude of the charge of one piece of tape is 2.132 raised to a power of negative 8 coulombs. Furthermore, the number of electrons lost due to excess charge was found to be 1.3 raised to a power of 11 electrons. Principles used in the lab include Newton's second law, which states that the net force is equal to the system's change in momentum over change in time, and the gravitational force, which is the product of an object's mass and the acceleration due to gravity near the Earth's surface. In addition, Coulomb's law gives us the electric force between two charges, which can be attracted or repulsed. As seen in the diagram, like charges repulse while opposite charges attract. The formula is 1 over 4 pi epsilon 0, which is Coulomb's constant, multiplied by the particle charges over the distance r squared and the unit vector r hat. For the lab setup, two pieces of tape were pressed together, then quickly ripped apart. Based on observations, the charged tapes were attracted to neutral objects such as a hand, but moved away from each other. This shows that the two pieces of tape were both positively charged and therefore experienced repulsion from like charges. Some assumptions made were ignoring air resistance, treating the tapes as point charges, and assuming that charges were identical and evenly distributed along both tapes. For the experiment, tape B was placed between two objects, creating a bridge. The length of tape B was 0.2 meters and its weight was 2 to the power of negative 4 kilograms. Next, tape A was moved underneath while tape B was observed to float, again showcasing repulsion. In this scenario, the system was tape B while the surroundings were tape A and everything else. The recorded distance between tape A and tape B while they were repulsed was 0.046 meters. To start with, the K constant, proton charge, and acceleration due to gravity near the Earth's surface were defined. Next, the initial conditions, including the original location of the tapes, was also defined. The forces on the system were calculated, then Coulomb's law formula was used to solve for Q, which was the charge of one individual tape. As seen, R, or the distance between charges, was found, then the magnitude and unit vector of R. Finally, the number of electrons lost was calculated and the model was computed. Potential errors in the experiment include rounding and accuracy in the distance measured between tape B and tape A. From the computational model, the magnitude of the gravitational force was found to be negative 1.96 raised to a power of negative 3 newtons. As stated in the beginning, the magnitude of a tape's charge was found to be 2.132 raised to a power of negative 8 coulombs, and the number of electrons lost was 1.3 raised to a power of 11. When calculated by hand, the magnitude of a tape's charge was roughly the same answer, but less accurate than the computational model. If electrons and protons had switched charges, the results would remain the same. Switching charges would not change the repulsion or attraction behaviors. To keep the tape as positively charged as possible, contact between neutral objects such as a hand were kept to a minimum. If a positively charged tape came into contact between a neutral object, it would begin to neutralize. This would then affect the effectiveness of the experiment as the tapes would not be equally charged. Thank you for watching.